Hi, my name is Jonathan Twombly, and I want to welcome you to my 3.6 physics video on pressure. Pressure, by definition, is basically the force exerted on something physically by something in contact with it. The main example I have today is the buildup of pressure in a space when the space is diminished while the particle count is not. The pressure buildup, when released, causes a large vibration via explosion, and this vibration causes a loud sound. The explosion is caused by the particles quickly flowing from an area of high pressure, in this case it will be inside the bottle, to an area of lower pressure, in this case outside of the bottle. The increased pressure inside the bottle also causes the water to vaporize into the air inside the bottle. When the pressure suddenly drops, the water recondenses into a mist, in best case scenario, inside the bottle. This might not be visible, so I'm going to try it a couple of times to see if it'll work. Let's see. That was the pressure, and you had the sound. In this case, I didn't quite have the mist, but that's because I'm in an area of higher pressure. That might be why the water isn't condensing correctly. I'm going to try this a couple more times to see if I can. Try number 2. There was a little bit of mist on that one, but I don't think you could see it in the video, so I'm going to try that one more. This is going to be my final try doing this, and I've added a little bit of water in the bottom to see if I can help get more water into the air when it pressurizes. Still not sure how well this will work, but I'm going to try it anyway. Oh, I don't think there's anything that time. Anyway, that's my first pressure experiment, and I have a little more explanation, but I'm going to go ahead. My next example is going to be a fan. Fans also work similarly with systems of higher pressure. They increase the pressure in front of the fan, and this causes the particles to flee away from the higher pressure area, just like in the bottle experiment, to an area of lower pressure, in this case in front of the fan. This leads to constant airflow, and this is also why a fan can push things over, because all the particles colliding with the object causes the object to move in the direction that the particles are moving. So in this case, we have a fan. I'm sure you can hear it. We have a bottle. The bottle gets blown over when the fan is on. But if I turn the fan around, the bottle will stay still. If I put the fan back at the bottle, the particles moving forward in the direction of airflow pushes the bottle off the end of the table. Last but not least, I wanted to relate this to my degree. My degree is game design, and pressure can be related to that because as we build stronger and more powerful machines for computing, we get closer to being able to simulate more of the physics we encounter in the real world. With these new abilities, we may be able to add more to games and revolutionize the industry. Once we can add pressure via particle count, we can use this as the basis for sound and explosions, creating a new form of game where things are less logic-based in a more computational manner and more physics-based like we have in the real world. A couple things I wanted to mention that I forgot to mention earlier on in the video was that this is the month of June in 2015, and my instructor's name is Corin Rambach. I'm not sure if I'm pronouncing that correctly. I'm sure I've screwed it up at least once.